Okay, Macha. Now we'll move on to next problems based on point of contraflexure. Look at the question. He has given that draw SFD and BMD for loading condition shown in figure and locate point of inflation, which is also called as point of contraflexure, if any. He has given the diagram wherein it is simply supported beam, more of a overhanging beam. Okay, there are two supports here subjected to UDL of load intensity 20 kilonewton per meter. To convert it into point load, I am going to multiply this load intensity with the length on which it is acting, that is 2 meter. So 20 into 2 will give me 40. So here I have represented in the form of point load 40 kilonewton acting exactly at the center, that is 1 meter from this support. Then there is a clockwise bending moment which is called as constant bending moment acting at point D, and at point E there is a load of 10 kilonewton point load. Now before proceeding further, let us analyze this constant bending moment. See, if I consider this constant bending moment here, see this horizontal section is a beam, and this constant bending moment is applied if we consider there is a vertical link connected to this beam, and if I apply right side force to the top section and left side force to the top section, there are forces and there is a perpendicular distance. That means these two will form a couple and they are moving in clockwise direction. Okay, so this force into perpendicular distance is represented by this symbol and it is given as 30 kilonewton meter. Now look, I'm going to solve it by moving from right to left. So if you consider this clockwise movement, what it will do is it will bend. See, if I move this to right side and this to left, it will try to bend the beam downward, right? If you come from right side, it will try to bend the beam downward because I'm pushing it right and I'm pushing this left, so it will try to bend the beam right side. When I'm coming from right side, if the beam is bending downward, then the bending moment will be negative, because this is the sign convention for positive bending moment. If the beam is lifting upward, then it is positive. If the beam is lifted downward, not lifted, if it is bent downward, then we'll take it as negative. So clockwise bending moment, while drawing bending moment diagram, we are going to take it as negative. But before that, we need to find the reaction RA and RB. For that, we are going to use different sign conventions. For summation of Fy equal to 0, upward forces will take them positive and downward will take a negative. RA and RC, this is the point C. RA and RC are positive because they are acting upward, and 40 is acting downward because of UDL, so it is minus 40, and here minus 10 is there, so plus RA plus RC minus 40 minus 10 equal to 0. RA and RC you keep it and at the left side, this you send it to right side, so it will become plus 50 is equal to RA plus RB. This will make equation 1. Similarly, summation of moment about A equal to 0. For summation of moment about A equal to 0, clockwise moment take it as positive and anti-clockwise moment take them as negative. Come from right side, there is a load of 10 kilonewton, it will give me clockwise moment with respect to point A. Follow the cursor, it is giving me clockwise moment. So plus 10 into distance is 1 plus 1 plus 1, 3 plus 2 is 5, plus 10 into 5. Here it is 10 into 5. Then there is a clockwise moment. Okay, for this bending moment, for calculating reaction, clockwise will take it as positive, but for bending moment, clockwise will take it as negative. Okay, so plus 30, I've written it as plus 30. Then there is reaction RC, which is acting upward, so RC into perpendicular distance is 3. Since it is giving me anti-clockwise movement, so minus RC into 3. And then because of UDL, point load is 40, it is acting in clockwise direction, so 40 into perpendicular distance is 1, so plus 40 into 1. From here I'll get the value of RC as 40 kilonewton. Substitute this value of RC here, you'll get the value of RA as 10 kilonewton. Now we'll go on to calculate we will go on to plot SFD and BMD. For that again I am marking left and right section at all the force points. Okay, I've already explained how to plot SFD and BMD. Come from right side. When I come from right side, there is no any force, so at this section the SF shear force is 0. Then consider this section and come from right side. There is one force 10 kilonewton acting downward. Coming from right, vertical force acting downward is positive, so plus 10 I am taking. From this section to this section, if you move, there is no any force which is acting again, so constant shear force will be acting. At this section or this section, again there is no force, there is movement. This is constant bending moment, so I can continue with the same shear force up to this section, because there is no any other forces acting. Now as soon as I reach this section, up to this section same shear force will be there. As soon as I reach to this section, one more force will be added, that is RC. To the right of this section, the force is upward force in the sense negative. So already I was having plus 10, now I am having minus 40. Plus 10 minus 40 will give me minus 30, so I am coming down to minus 30. From this section to this section there is no any other force, so minus 30 will continue. Then as soon as I move from this section to this section, there is one more force, that is 40 and vertically downward. So I was having minus 30 here, and here I am having plus 40, so it will become plus 40 minus 30 will give me plus 10. Since it is UDL, I am going to join it with straight line for shear force diagram. Then when I come from this section to this section, there is one more force added, that is 10. But since to the right side of this section, this force is upward, which will give me negative 10. So already I was having plus 10, now I'll be having minus 10, which will give me 0 value. Here you can see that shear force is crossing this 0 line at this point. So this is a point where bending moment will be maximum in the sense positive bending moment. Look here, after drawing this you will get like this somewhat. This is positive bending moment maximum. Right side if you look, there is no any positive bending moment. This is the value of maximum positive bending moment. There is negative bending moment, but look at this one, only this is the maximum value of positive bending moment, which I need to determine. Okay, we'll see about it afterwards. Now for plotting bending moment diagram, again consider only one section, but at constant bending moment I need to consider both the sections. Again remember this, whenever there is a constant bending moment, consider both the section. Come from right side, consider this section. Come from right side, there is a force, but bending moment is force into perpendicular distance. There is no perpendicular distance, distance is 0. So at this point bending moment is 0. First draw the horizontal line which represents 0 bending moment. Okay, now at this point bending moment is 0. Now consider this section. Whenever there is constant bending moment, always consider both the section. Now consider first right section. For right section, come from right side, there is a force of 10 kilonewton which is bending the beam downward like this. With respect to this section, it is bending the beam downward, so we need to take it as minus 10 into distance is 1, so it will become minus 10 kilonewton meter. So I am joining it with this straight line, minus 10 kilonewton meter. Then as soon as I move to this section, left section, then what happens is this clockwise bending moment is acting at this point. So when I come from right side, there is this force and perpendicular distance, and also this moment acting at this point. So this is minus 10 into 1, and this clockwise, like I told here, it will bend the beam downward when I come from right side. So we need to take this also minus 30. So minus 10 minus 30 will give me minus 40. So from minus 10 I am going to minus 40. Next, come to this section. You can take this section or this section. Now when I take this section, for example, come from right side, there is 10 and perpendicular distance is 2, and it will bend the beam downwards. So minus 10 into 2 is minus 20, clockwise is minus 30. So at this section, minus 10 into 2 is minus 20, and minus 30 will give me minus 50. Of course there is a force here, but the perpendicular distance is 0, so this force will not have any effect, only these two will have the effects. So from minus 40 I am moving to minus 50 kilonewton meter. Now come to this section. I can consider this section or this section, both are fine. Suppose I consider this section. Instead of coming from right, it is better if you go from left, because only two forces are there, one is this one and other is UDL. Or you can come from right also, it is not a big problem. Okay, if I consider this section, look at this force, 10 kilonewton. It is bending the beam upward in the sense positive. Plus 10 into 2 will give me 20 kilonewton meter, and this force, because of UDL 40, it is bending the beam downward, like this, downward. So minus 40 into half distance is 1. So minus 40 into 1 is minus 40. Here I was having plus 10 into 2 plus 20, and minus 40 will give me minus 20. Okay, so here I am coming minus, I am writing it as minus 20 kilonewton meter. Or if you come from right side also, it is fine. If you come from right side, 10 downward, so minus 10 into 3, minus 30 it will become. Okay, minus 10 into 3 is minus 30. Minus 30 will clockwise minus 30, so it is minus 60. Minus 60, and here you are having positive because it will lift upwards. 40 into 1 will give me plus 40. Minus 60 and plus 40 will give me minus 20. So you come from right or come from left. Here I have written the calculation. See, minus 10 into 3, minus 10 into 3, and this clockwise is minus 30. I have written minus 30, and this is positive because it is lifting the beam upward if I come from right side with respect to this section. So plus 40 into 1, I have written here plus 40 into 1, which will give me minus 20 kilonewton meter. So here at this section it is minus 20. Now here, if I consider this section, consider from left itself, no need of going from right. Okay, from left if you consider this section or this section, force into perpendicular distance is 0. So at this section obviously bending moment is 0. Now don't join the bending moment directly from minus 20 to 0 like this. Okay, don't join, because we know that there is a change of shear force from positive to negative, or there is a shear force of 0 at this point. So obviously we are going to have maximum bending moment at this point. So instead of joining curve from this point to this point, wait for a second and calculate the maximum bending moment at this section, because shear force at this point is 0. Now to calculate maximum bending moment, I need to first know the distance x. For that, what I am going to do is I am going to consider this triangle and this triangle, which I have already explained. I considered it here. Height at this triangle is 10, and I have taken this distance which I need to calculate as x. Here I have written x. Now consider this triangle, value is minus 30, but only take 30, don't take minus. And distance, this total distance was 2. Since I have taken this as x, so it will become 2 minus x. Here I have taken 2 minus x. Then from property of similar triangle, opposite 10 divided by x, here also opposite 30 divided by 2 minus x. Cross multiply and you will get the value of x as 0.5. So from here the value of distance x is 0.5 meter. Okay, so at this point I will get the value of bending moment as maximum. So what I need to do is I need to calculate bending moment at this section, that is 0.5 meter from left end. So I need to cut the beam and take a section at this point. I can either take the left section or I can take the right section. Both I will get the value as same. But if you use your common sense, it is better to consider the left section. Okay, you will have only UDL and you will have this reaction. If you come from right side, you will have point load, you will have bending moment, constant bending moment, you will have reaction RC, and if I take section here, also some part of UDL. So consider left section. That is what I have done here. Okay, but UDL you need to consider only up to x equal to 0.5, not up to 2 meter. Okay, come from left, there is one point load of 10 kilonewton and UDL, okay, which is having a load intensity of 20 kilonewton per meter. only up to a distance of 0.5. That is what I have done here. Okay, there is a reaction force of 10 kilonewton and UDL of up to a distance only of 0.5, because I've got the value of x as 0.5, and the intensity was 20 kilonewton per meter. When I convert this 20 kilonewton per meter, multiply it with 0.5, so it will become 10 kilonewton. Okay, so convert this UDL into point load, it will become 10 kilonewton, and this load will be acting center of 0.5, that is 0.25 meter from this section XX. Now I can find what is the bending moment at section XX. Come from left, because you considered left section. There is a force 10 and perpendicular distance is 0.5. It is lifting the beam upward, so we'll take it as positive, so plus 10 into 0.5. Next, this force will bend the beam in downward direction like this. Okay, downward in the sense negative. So minus 10 into distance is 0.25, minus 10 into distance is 0.25. From this I got the bending moment as 2.5 kilonewton meter, which is positive. That means here the bending moment, maximum bending moment, positive bending moment will be 2.5 kilonewton meter. So I need to join from this curve, I need to take positive up to 2.5, and then from here I need to get it back to 0. But look at the curve, it is parabolic because there is a UDL here. Now this we already know. Now one more step we need to do is calculation of point of contraflexure or point of inflation. What is point of inflation? It is a point where bending moment is 0. That is this point. If you look at bending moment diagram, here the value of bending moment is 0. It is going from positive to negative or negative to positive. So I need to find what is the distance of this point P. How I am going to find? Let me call this a section YY, and this section, let me consider it is at a distance of Y from this free end. Okay, it is at a distance of Y from the free end. I need to find what is this value. This I have written after finding the value. Okay, so what I'll do again to find this distance, I know that at this section what is the value of bending moment? It is 0. Okay, so I'll cut a section at this point. I'll consider it as section YY. I don't know what is the distance from this end to this end. Let me consider it as Y. You can also consider from right end, but the calculation will become complicated because number of forces are more. So consider from left end. I'm taking a section YY at this point. Okay, I'm considering all the forces from left end. When I add all the bending moments at this section, I should get the value as 0, because bending moment at this point is 0. That is what I am doing here. Okay, I am taking a section YY and distance from this end is Y. Okay, there is a load of 10 kilonewton acting. This load is 10 kilonewton acting at this point, and UDL I need to consider it only up to a section Y. He has given the load intensity as 20 kilonewton per meter. To convert it into point load, I need to multiply 20 with distance on which it is acting, that is Y. So point load will become 20 into Y, and distance it is acting exactly at the center, that is Y by 2 from section YY. Okay, now when I take bending moment because of these two forces with respect to YY, it should be 0. So bending moment with respect to YY equal to 0. So what it will become is, what we'll get is, this force will lift the beam upward with respect to section YY. So beam will look somewhat in this manner. So it is positive. So plus 10 into perpendicular distance is Y. Next, this force is 20Y, which will bend the beam downward. So negative, minus 20Y. Minus 20Y is the force, and perpendicular distance is Y by 2. When I add these two bending moment at section YY, I should get it as 0. 10Y minus 20 by 2 will become 10Y square equal to 0. From here you will get the value of Y as 1 meter. That is, from this distance, from left end, point of contraflexure or point where bending moment is 0 is at a distance of Y equal to 1 meter. This is about this problem. Thank you.